Good morning.
Good morning, Denise. How are you doing?
I'm good. I'm okay. How are you?
Good, good. What's the word? I don't know, I lost the word, but you're not getting out of the house much. You're not feeling too,
No, not at all.
that's not bothering you?
Well, yeah, I'm used to being around and about and running errands and just walking around. But
Yeah,
I mean, if that means we stay safe, then, I'd rather just, I guess, just stay in until this is all over, or at least controlled.
yeah, yeah. That's an interesting question and thought. I don't know, but all we can do is do what we can. So
Mm-hmm.
I admire the courage of all those people that are in the middle of things, you know?
Yeah, I actually worry a lot because those
Yeah.
are actually both of my parents are on the front lines.
Oh, yeah, that's scary. Yeah.
Yeah, so I pray that they're taking care of themselves
Mm,
and that
yes.
the odds are in
Okay.
their favor.
Yes. Okay, well, what can I do for you, Denise? How's your home? Well, actually, I looked at all the class and it looks like you're doing well, except for a couple problems I noticed.
Yeah, you know what? There's like two that I did, but because I saw the tutorial, but not
Okay.
because I actually understood it. So, for
Okay.
example, number five, apparently it's that the integral diverges, but when I did it, I don't know where I messed up that I actually got a numerical value, and I'm like,
Okay.
how is it diverging? So I'm confused on number five. But of course, my
Okay.
answer is already there, but I don't know how they're getting that answer. I just put the answer.
Okay. So let me find that one. And let's see here. So, mm, there you are. And 8.8. And number 5. Okay. Okay. So, oh yeah, I remember you had asked this before, and we never got to it. You know, because I think we
Yeah.
did another one instead first. So, let's see if I can find some room here. Okay. So, okay. So I'm gonna write down the integral, and this is 8.8, number 5. The integral from 6 to 7, and let's get that 12 out in front. 1 over. Okay, so switch to my notebook. Did you see my WebAssign page right now? Or my
Yes.
notebook? Okay, just wondering. Okay, so, okay. Okay, so here's the number, the problem exercise, and we notice it's from 6 to 7. So there's no infinite limit of integration there.
Mm-hmm.
So therefore, to be improper, then there's only one other choice. So it has to be undefined somewhere.
Mm-hmm.
And where is this denominator undefined?
At six.
Yeah, because 6 minus 6 will be 0, to the 3
Mm-hmm.
halves is 0. So we have this vertical asymptote asymptotic behavior at x equals 6. So, and we want to know the area from 6 to 7. So this is where the vertical asymptote is going to be, and the graph will look something like this. And then it's going to come down. I mean, so here is where we have this infinite vertical sliver of area, and that's what makes it improper, huh?
Mm-hmm.
And then we're going to find out as we move closer and closer to 6 from which side?
From the right?
What happens to this? What happens when we keep accumulating this little infinite vertical sliver of area? Does it converge towards a finite number or not? So again, does it like get closer and closer? Let's just pick a number. If you say 15 square units, does this get closer and closer to 15 but never make it to 15?
Mm-hmm.
Now it's back. Can you see okay?
Yes. Mm-hmm. Yes.
Okay, so okay, so oh gosh. Okay, so now we're just going to integrate, and we change the 12 out here is just a multiplied constant. We could leave it there, but I just prefer to take it out. So instead of writing 6, this is where we have that infinite discontinuity, and so we write a b here instead of a 6, and
Yes.
we then take the limit as b approaches, and then you said 6 from which side are we getting
The
closer and
right.
closer? From the right. And now we have this integral, this integrand expression. And now we integrate it. And so for the moment, the limit is not our concern, initially at least. It is integrating. And then when we have the antiderivative expression, we evaluate it from 7 to b. And then once that's done, then we worry about the limit. We could have the 12 inside here or outside. It doesn't matter.
Okay.
Okay. So to integrate this, if we change this just to a single letter with the renaming or the use substitution, then we would have like a w to the 3/2 or a u to the 3/2, whichever letter you want besides x. And then when so if you had 1 over w to the 3/2, we could move that up and it'd be w to the negative 3/2, which then we could use the power rule, provided when we replace dx with the dw that everything works out, yeah?
Okay.
Okay, so what letter what, are you using U more often than W or whatever?
I use you a lot, actually.
Yes. So, okay. I'm just a rebel, huh? I have to use a different letter, no.
Yeah.
Okay, so, okay, so then if we let U equal X minus 6, then, I guess I'll put the 12 right on the other side. So now we're gonna have, and technically, because this is with respect to x, at x equals b, at x equals 7. So technically, we're not supposed to write b and 7 there, although it doesn't destroy the problem, but I'm just pointing it out. And so then what would be right here? We said this would become a what?
U to the negative 3/2 if you move it up.
Good, so let's just skip that little step and move it up. And then we're gonna have to have a du here, huh? And to get that du, so you could do it the traditional way, or you could just plop it there if you will. And so we need to differentiate this renaming statement. And what does this become here? When we differentiate it with respect to x.
Du over dx.
Good. And then this dx is gonna move over here by multiplication. And then what's the derivative this side?
It's going to be just dx, or 1 dx.
So if we now check, all this is the same. The u to the negative 3/2 takes care of this piece. And the du really represents this 1 dx, which is what we had already. So is this okay so far?
Yes. Yeah.
Okay. So now we have rewritten our integrand expression inside so that we can now use the power rule for anti-differentiation. And so now we do that. So then we use the power rule. So what do we do there?
You add 1, so it's going to be a negative 1/2.
Good. Negative 3/2 plus 1 is negative 1/2. And then divide by
a negative 1/2.
which is the same, dividing by negative 1/2 is the same as multiplying by
2.
negative 2.
Yes.
So far, so good?
Mm-hmm.
And then we still have to evaluate it. And again, I wouldn't really be technically correct to put a b here and a 7 because that's with respect to x still. So I'm just going to wait till we change this back into x's, okay?
Okay.
So now limit as b approaches the 6. And the 12 times negative 2 is negative
24.
Instead of u to the negative 1/2, I think it's safer if we move it underneath and become positive 1/2. And then,
Do
but
we have to?
You don't have to now. You don't have to ever. It's just that if you left it on the top, you're gonna have, if you left it there, then you would have negative 24. And the u, same thing here, it's x minus 6. And here you would have negative 1/2 x minus 6. And then from x equals b to x equals 7. And then we still have limit in front. So that is perfectly correct. And it's the same as this down here. Oops, that's a b. And that's a 7. So either way, it's correct. And we just move forward and then we input these values. So I think, just my opinion, if you have a large, say you have 1,000 students learning this, maybe they get more likely to get mixed up when they start putting the numbers in here and leave it as negative 1/2. It may or may not cause them to get tripped up and make an error.
Okay. I thought it was to change the answer. I'm like, why do we have to do this step? I thought it was like a must.
No, but just realize eventually when you start taking the limit, it's probably going to be helpful to move this underneath so you can understand what the limit's going to be. It's probably easier to understand it that way.
Okay.
But it's not going to change the answer, no, unless we make a mistake. Yeah.
Okay.
So is it okay if I keep going this way?
Yeah.
Okay. So and now we are going to input and using, so this is just another way to write it, at x equals 7 and at x equals b. Okay, so we're going to have here the 1 over, because this is the integrand. I mean, not the integrand, but the antiderivative expression. That's just sitting down in front. So here we have x minus 6 to the 1/2. That's a 6. And then we have, again, a minus 6. And yeah.
Mm-hmm.
Too many parentheses here. 1/2. And that's positive 1/2. And then instead of x, we're just going to put what on this one? We're going to put
A 7.
And instead of x, we're going to put
B.
a b. Okay. So, and now we take the limit. So we don't write the limit anymore. And now, as soon as we say we're going to take the limit, then it's only going to affect the expressions over here where there's a
It
b.
has the B. Okay.
Yeah, so it doesn't change anything on this one because there's no b here. So this is just going to either, turn into a finite number. So 7 minus 6 is the 1, is 1 to the 1/2 is still, that's like
1.
the square root of 1. And then 1 divided by 1 is
1.
1. So all I was trying to say is if we had it up here and we would have had 7 minus 6 to the negative 1/2, and then right here minus b minus 6 to the negative 1/2, it may or may not trip people up when they have to take this limit here and with a negative exponent, or the same thing here. It may or may not. Okay, that's all. So minus, so what's going to happen right here? Either we're going to get, so this is where the b is. So when we take the limit, we hope for the best scenario, which is the quickest one, is when we get a determinant form. So finite numerical value, infinity or negative infinity, because then it's determined and we have the determined value and we're done. Well, we're virtually done. And if we get 1 over 0, because there's a 1 there, then that means it's undefined, and then we go back, because this is a one-sided limit here, we go back and use logic and say like 6.000001 or something. And then we figure out the limit by that logic method. If we get 0 over 0 or infinity over infinity when we take the limit, then that's a friendly indeterminate. We use what rule there?
L'Hopital's.
Good. And if we get, when we take the limit and we get an unfriendly indeterminate, well, then we have to rewrite or manipulate this algebraic expression somehow so that it turns into a friendly indeterminate, which then we can use L'Hopital's. So I hope that makes sense. I'm trying to put it all together in our minds so that whenever you take a limit, those are the things that can happen to us. Well, there's one more thing. It could be that oscillating behavior that we've talked about a couple of times. Yeah?
Okay.
Okay. So, well, which of these is going to happen? If you just put 6 right here, minus 6, then that's going to be what, of course?
0.
And the square root of 0 is still 0. And 1 over 0, that's
undefined.
That's undefined, right? So that means what that really means is this answer right here, this 0 really ends up becoming, when we explore or we dig deeper and we look at the right side limit on the 6, then we're going to get a tiny, 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 tiny number, and it's going to either be positive or negative. And then, so any tiny number, a tinier and tinier number divides into 1 more and more and more. So this is when we're going to get either what?
Infinity or negative infinity?
Very good. So that hopefully gives us comfort that we already know that that's what's going to happen. And then we're not lost, because otherwise it's just all a big mystery, yeah? So it sounds like you have a good grasp of all that. So that's great. So, okay, so now we have to use this logic, and again, it's really nice if we know, hey, this is really going to turn in from, instead of a 0, into a tiny, tiny number. And it's either going to be a positive 1 or a negative 1. Yeah.
The tiny positive number, do you mean like a number close to 6 approaching from the right? So 6.000000001?
That's what's going to go right here. But
Uh-huh.
when we subtract it, after you put that 6.0000001 and you subtract the 6 and take the square root, then this is still going to be, there's a reason why we got 0 here, because well, first of all, that's what happened when you put the 6. But what that really means is, if when we do analyze it at a more deeper level, then the 0 is going to go away and we're going to write a tiny, tiny number that's closer and closer to 0. Yeah.
Mm-hmm.
Because this wasn't enough for us to determine the limit. So we dig
Okay.
deeper, we look at this right side limit, and we're still going to get a 1 on the top. But right here, we're going to get a number that's really, really close to 0 anyway, just not saying literally 0. It's going to be a tiny, tiny number that gets closer and closer to 0, depending on how close you get to 6 from the right side, and then substitute it in.
Okay.
So did I answer your question?
Yeah, yeah.
Okay. So what happens when you put, like you just said, so this is not going to get closer to 6.00001. This is always going to be close to 0. It's just you're not going to write 0. You're going to write tiny, tiny number, positive or negative. But here's where the B is, right? And so here is where you put whatever this says. And this means, like you just said, 6.0000, as many zeros you want, 1, or I mean, it doesn't have to be 1, but it's a number really close to 0. I mean, to 6.
To 6, yeah.
Right side. So help me out here. So when we do this, what are we gonna get?
We're gonna get a very tiny positive number. And that tiny positive number to the half is gonna be another very, very tiny positive number.
Very good. And
so that tiny positive number fits into 1 in infinite times.
Very good. And because it's positive over positive is positive. So if we put tiny, tiny positive number here and say 1 divided by 0.001, for example, you're going to get a positive answer, but it's going to be, I don't know what, it's going to be a large number, like 1,000 or whatever. And you make this tinier and you put it in a calculator, 1 divided by 0.000001, it's going to be like 1,000,000 or something. And it just gets bigger and bigger, huh? So that's why we know this was going to have to become infinity or negative infinity anyway. Right. Does that make sense?
Yes.
So then all this, after the subtraction sign, this limit, which is always the interesting part for us to figure out when we have these improper integrals, is well, now we know we now know the determinant value. We didn't end up getting an indeterminate, so we didn't have a friendly indeterminate, so we didn't have to use L'Hopital's rule. We didn't have an unfriendly indeterminate, which then would have required to rewrite this somehow or do something to this, and so forth. But we did have one little obstacle to overcome, which was when we did just put the 6, a direct substitution on the limit, we got an undefined number. But that's really a more simplistic type of situation that we have to overcome, because we know that it's either going to be infinity or negative infinity. Is that okay?
Yes.
So here we're going to write minus infinity. And this is not infinity over infinity, like we were just saying. This is determinant. It's just not the finite numerical value type, right?
Right.
So now we continue. So 1 minus infinity is still, well, not still, but what's that?
A negative infinity?
So this will become negative infinity times
a negative 24,
which will become
a positive infinity.
So what that means then is, so this graph right here, the integral from 6 to 7, and this is the part that made it improper, this infinite discontinuity. So as we move in closer and closer to 6, that gives us more and more of this vertical sliver that goes up forever. And that little infinite, smaller and smaller sliver of area did not converge towards some finite numerical value, like get closer and closer to 9, but never make it to 9, but it passes 9, it passes 10, and so forth. So that's why we get infinity.
Okay, so it diverges.
So this improper integral, it diverges, like you said. And it's correct to say just diverges. It's correct to say this integral, improper integral, does not exist. And it's also, when it diverges, then it's either to infinity, to negative infinity. It could also be because of an oscillating situation, but for this case, it was to infinity. So infinity is more specific than just saying diverges, because we know that the area is getting bigger and bigger to positive infinity versus negative infinity. But they may or may not ask you in the WebAssign, the authors may ask you if the integral, improper integral, does not exist, or in other words, it doesn't converge, then you either write, maybe they just say write diverges all the time, or they might say, if it does diverge, state whether it's infinity or negative infinity. You know, it just depends on how the author chose to request the answer.
Right.
Does that make sense?
Yeah.
Okay, so we go back to WebAssign and we put diverges and we said it was infinity. So, and where's my, I guess, oh, I was like, where's my little box over here? But it's because they don't want us to type infinity, do they? So that's why that little box doesn't pop up. And we just type diverges.
Okay.
And I don't have it. And I don't know, sometimes they're inconsistent. They say capital and then a lowercase is okay. And then another time they say capital and you put lowercase and it marks it wrong. I guess it's just it's problematic on how they program it. And so no big deal there, okay?
Okay.
Okay. Does that make sense?
Yeah.
Oh, and here's that.
I don't know what I was doing.
What's that?
I don't know what I was doing that I actually got a number, but.
Do you think it had to do with you leaving it as a -1/2?
Maybe. I don't know. I threw the paper away. Oh. Well, let me see. I might still have it. Oh, no, yeah. I erased. Oh, no, yeah. I did keep it as a negative. I'm watching. I'm seeing my eraser markings, and yeah, I kept it as a negative.
And I do think, like I said earlier, that it is potentially more problematic and can cause people to, makes it more likely to make an error. Yeah.
Yep.
So that's why I'm suggesting to move it underneath, because now when it's underneath, now you get more comfortable. Oh, I get undefined. I get 1/0 or something, or I get infinity over infinity or whatever. But if you leave it up there, it's more likely for us to lose the feeling of what happens when you take the limit, when it's up still there in the numerator with the negative exponent.
Okay.
Does that make sense?
Yeah. I think I'm just going to play it safe and make the exponent positive.
Yeah, I would do that too. Okay, Denise? So I don't know how you're doing on the rest of them, but I do have a class that starts in a few minutes. So you can always, you're welcome. Tomorrow I'll have an office hour really for either, for any of my classes. So um, at the same time. And if for some reason I run out or there's more people that want to ask questions, I can always say, well, how about this group come back in a few minutes and another group or whatever, you know?
Yeah.
But Friday is kind of like a general office hour for whoever wants to join. Yeah.
Okay, cool. So then, yeah, because I still have 3 more questions I'd like to go over. So I think I'm gonna wait on that till tomorrow then.
Okay.
I tried them already. I did them yesterday so that I would be ready to ask you today, but yeah, I kept getting stuck. And then on one of them, it looks like a weird indeterminate. So it's like never seen that before. I'm pretty sure I messed up, but I guess I'll just wait for you on that for tomorrow.
Which numbers were they?
Well, I tried number 10 and then 19. I don't know if I did it right, and then 21.
Yeah, 19 is different with that trigonometric function. 21 shouldn't take us too long to look at. And then what was the other one was 10?
10, uh-huh. I was
Oh, that's
following
what
how we did 11, but I don't know.
probably the negative infinity messed us up a little bit. Yeah.
Yeah.
Versus the positive infinity. But
Mm-hmm.
again, make sure if you have a negative exponent that once you are about to evaluate and put the 0 in and the b, make sure once you do that, you then move whatever had a negative exponent and move it underneath to the bottom.
Yeah, I did, and I still
Okay.
got confused. So
Okay.
that's what I'm wondering.
Okay. So it kind of will be, well, something like this, but yeah, we can wait till tomorrow, okay?
Cool. Okay.
Okay. Okay, Denise, well, nice talking to you, and I hope that helps, and we'll see you soon, okay?
Yes. Okay. Thank you.
You're welcome. Goodbye.
Bye bye.